Hello everyone, this question is about differential equations. The variables x and y satisfy the differential equation cos 2x dy dx equals 4 tangent 2x over sine squared 3y, where x is between 0 and 1/4 pi. It is given that y equals 0 when x equals 1/6 pi. Solve the differential equation to obtain the value of x when y equals 1/6 pi. Give your answer in 3DP 8 marks. So, to solve differential equations, the first step is to separate the variables, which means we want everything with y on one side, everything with x on the other side. So here we can just multiply both sides by sine squared 3y. So if we do this, of course they're gonna cancel out, so we're gonna have sine squared 3y on the left like this. And if we hold on, okay, so if we multiply both sides by dx now, so they're gonna cancel out, so we have dx on the right like this. And now if we divide both sides by cos 2x, we're gonna get cos 2x on the right like this. So basically we just multiply and divide the equation throughout, so that everything with y on the left and everything with x on the right. That's the first step, separating the variables. Now the next step is to integrate both sides actually, but we cannot integrate sine squared something or 4 tangent 2x over cos 2x directly. So we're gonna have to use some trigonometric identities here. So in the MF19 you have this formula. So from this MF19 formula, if you rearrange, so you move this to the left, you get 2 sine squared theta, and you move this to the right, you get minus cos 2 theta, and then you divide by 2. So basically if you rearrange this MF19 formula, you're gonna get this. And then if we are dealing with 3y here, not theta. So if theta is 3y, of course 2 theta is 6y. So we can replace sine squared 3y with this guy here. So we replace sine squared 3y with 1/2 minus 1/2 cos 6y. So that's the left hand side. Now the right hand side. So we have this definition of secant, which is not in the MF19. So you have to know that secant is 1 over cos, cosecant is 1 over sine, cotangent is 1 over tangent. So this is 1 over cos, so it's secant, and we still have 4 tangent to x. So now we are ready to integrate both sides. On the left, the integral of 1/2 is just 1/2 y, and the integral of cos is sine, but we have to divide by 6 because of the 6, the chain rule. And for this guy here, if you look at the MF19, this is not in the integration formula but differentiation. So if you differentiate secant, you get secant tangent, which means if you integrate secant x tangent x, of course you're gonna get secant. So although this is in the differentiation part of the MF19, we can use it to integrate. So using this concept here, we get secant 2x, but divided by 2 because of the 2 chain rule. So after we integrate both sides, don't forget to add the constant of integration on one side to the right usually. And now we need to find the c. So this is already the general solution of the differential equation, but to find the c, we need to plug in the y and the x value. So the y is 0, the x is 1/6 pi, the y is 0, x is 1/6 pi, and find the c. So here, when we plug in 0 here, it's going to be 0. This is sine 0, which is 0, and this is secant 1/3 pi, and secant is 1/cos. Cos 1/3 pi is actually 1/2. So just use your calculator. You're gonna get 4 from here, which means the c must be -4. After you find the c, of course you replace this c with -4, just rewrite, but the c is -4. You get the particular solution. So this is called the particular solution. If you read the question again, we need to find the x when the y is 1/6 pi. So this y is 1/6 pi, this y is 1/6 pi. Now you need to find this x. So 1/2 times 1/6 is 1/12, and 6 times 1/6 is 1, so just pi. Sine pi is 0, so 4/2 is 2, and secant is 1/cos. So we have 2 times 1/cos. Move the -4 to the right, you get, left, you get +4. And then you basically switch the cos 2x and the 4 plus pi/12. You multiply both sides by cos 2x, right? So cancel out, you get cos 2x on the left, and at the same time you divide by 4 plus pi/12, so they cancel out. Divide by 4 plus pi/12. That's why we get cos 2x on the left and 2/4 plus pi/12 on the right. Okay, so now we inverse cos both sides. So we have 2x equals inverse cos the whole thing, divide by 2, use your calculator, you get the answer, and we have to use radians, of course, because this is calculus. We cannot use degrees. Right, I'll see you again next time.